Welcome to Learning with Philemon. In this video, we will be looking at some of the different fuels we use in society, namely coal, natural gas, and petroleum. Alkanes will be mentioned throughout the video, so please watch the video Alkanes before. Coal is formed from dead plant materials. As the plant materials are buried underground, the heat and pressure transform them into their constituent elements over millions of years. Coal mainly consists of carbon, but also of elements such as hydrogen, sulfur, oxygen, and nitrogen. As seen in the picture, coal is a solid of dark color. If you study biology, you know that living organisms consist mainly of the aforementioned elements. Coal is burnt to produce carbon dioxide, CO2, and heat. This is a combustion reaction like alkanes undergo. The heat from the combustion of coal is used to boil water. The steam drives turbines that turn generators that produce electricity. Knowledge of this electricity generating process is not required in GCSE chemistry, as it is covered in more detail in the physics course. Note that the same process to generate electricity is used whether you are burning coal, natural gas, or petroleum. Now let's take a look at natural gas. Natural gas is formed from organic matter, primarily marine microorganisms. Like with coal, the heat and pressure that this matter is subjected to decomposes the material. Unlike coal, a mixture of gaseous hydrocarbons is formed. Natural gas primarily comprises of methane gas, CH4. As seen in the alkanes video, alkanes undergo combustion to form carbon dioxide and water, H2O. Natural gas can be used for heating in Bunsen burners, cooking in gas stoves, as can be seen in this picture, or to produce electricity, as discussed in the previous slide. Methane is a colorless gas, but when it undergoes complete combustion, a blue flame is produced. Now let's take a look at petroleum. Petroleum, or crude oil, like coal and natural gas, is formed from the application of heat and pressure on dead organisms buried underneath sedimentary rock. Petroleum consists mainly of a mixture of hydrocarbons. Remember that hydrocarbons are compounds that contain only carbon and hydrogen atoms. As seen in the picture, petroleum is a dark liquid. Before use, the different hydrocarbons in petroleum are separated by fractional distillation. In this video, we will only focus on the alkanes present in petroleum. In fractional distillation, the mixture is heated to a temperature of around 400 degrees Celsius, so that all the components become gases. The gases enter the bottom of the fractioning column, which is warmer at the bottom and colder at the top. Each alkane in the mixture has a different boiling point and condensation point. Note that the boiling point and condensation point of a substance are at the same temperature. Water boils at 100 degrees Celsius, but also condenses at 100 degrees Celsius. Which process occurs depends on whether the substance is being heated or cooled. For more on state changes, please watch the kinetic theory of matter video. Longer alkanes have higher boiling condensation points than shorter alkanes. For example, butane, C4H10, which consists of a 4-carbon atom chain, has a boiling point of -1 degree Celsius. Octane, C8H18, which consists of an 8-carbon atom chain, has a boiling point of approximately 125.6 degrees Celsius. For an explanation on why the boiling point increases with the size of the molecule, watch the IB video Intermolecular Forces. As each gaseous alkane rises up the column, it condenses at different points, based on its condensation point. Note that condensing means a gas turning into a liquid. The liquid is formed and is collected. Octane would condense around this point in the column and be collected. Alkanes with longer carbon chains, more carbon atoms, would condense at a lower point. Butane has a lower boiling point than 50 degrees Celsius, so it does not condense. It leaves the column at the top as a gas alongside the smaller alkanes, propane, ethane, and methane. The following animation helps us visualize this process. In this animation, you can see longer chain alkanes be collected near the bottom of the fractioning column. Shorter chain alkanes are collected at a higher point in the fractioning column. The link to the animation is in the description. Now let's see how each one of these alkanes is used. The mixtures of alkanes collected at different temperatures are called fractions. The alkanes of each fraction are used in different applications in everyday life. Shorter alkanes, consisting of 1 to 4 carbons, are gases at room temperature. They are contained in bottles and are used for heating or cooking as discussed earlier. Longer alkanes are liquids at room temperature and are used as fuels in cars or jets. Bitumen consists of very long alkanes. It is a sticky, viscous liquid that holds asphalt together in roads. In summary, we have seen how fuels are formed, how they are separated, and what they can be used for. As there was a lot of information in this video, I recommend watching it a few times and taking some notes. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.